Hi everyone, I'm Mr. Reeby, Principal of Vanderveer Elementary School.
And I'm Dr. Tian, Superintendent of Schools.
We are so excited to welcome everyone to our Vanderveer Evening Learning Academy.
You are all in for weeks and weeks of enjoyment.
You will be learning alongside your very own Vanderveer teachers.
Also, we have teachers and administrators from across the district that will be bringing you fun learning experiences.
You will become scientists, engineers, mathematicians, writers, world explorers, and learn to communicate in different languages as you explore concepts in math, reading, writing, science, social studies, world language, and so many more.
Thank you so much for joining us tonight, and we encourage you to visit often and view other lessons in our learning library as we add to the videos each week. Enjoy.
Have you ever thought about why things sink and float? Today, what we are going to do is we're going to think about and learn about why some objects sink and some objects float. Let's first take a look at some objects and predict if they are going to sink or float. So we have a Coca-Cola, we have a sparkling water, we have a Diet Coke, and last, we have a ginger ale. So if we put these in water, what do you think is going to happen? Are they going to sink or float? Let's go ahead and see. First, we have our ginger ale. Do you think the ginger ale is going to sink or float? Let me hear some guesses. Let's find out. Now, what do you think about the sparkling water? Is the sparkling water going to sink or float? Shout it out. Those are some good guesses. I heard someone say they think it's going to sink because of the bubbles. Let's find out. Now, what do you think about the Diet Coke? Is the Diet Coke going to sink or float? Let me hear your guesses. Shout them out. Ooh, those are some good guesses. Let's go and put it in the water and see what happens. Now, what do you think about a Coca-Cola? Is it going to sink or float? Let me hear your guesses. Okay, some of you said it's going to float because the Diet Coke floated, and some of you said it's going to sink. Let's go ahead and test it out. Now, why do you think some of these sunk and some of them floated? Well, it has to do with density. Let's take a closer look and try to define density. We are going to try to define density. We have 2 cups of water. What we're going to do is we're going to pack one with a lot of sugar and one with a little bit of sugar, and then pour them together and see how they behave. So the first step that we are going to do is we are going to add food coloring to both of them. So we are going to add red to 1 cup of water And then we are going to add green to the other cup of water. Next, we are going to take some sugar and add a lot of sugar to the red one, and a little bit of sugar to the green one. So here goes 1 tablespoon in the red cup of water. Here goes 2 tablespoons, 3 tablespoons, 4 tablespoons. Now the other one, the green cup, will add 1 tablespoon, 2 tablespoons. So the red cup has twice as much sugar as the green one. We're now going to stir them up. If we start thinking about these 2 cups of water, the red has a lot of sugar. So all the atoms and all the particles are taking up a lot of space. Imagine being on a train and it being super crowded. The sugar is all tightly in there. The green one has less sugar. So if you're on a subway, you still have some room on the train. But there's still space for you to move around a little bit. So the red cup is really tightly packed together, where the green is not so much. Now let's see what happens when we pour the green cup on top of the red cup. So I poured the red cup into the red sugar water into a cup. I'm now going to take a turkey baster and I'm going to put the green one into the cup. Let's see what happens. Any predictions of what's going to happen? Let's find out. So I'm adding the green slowly in, and you can see the green's not going all the way to the bottom. It's kind of staying in the middle to the top. Let's add some more and see what happens. So you can see that the orange or the red is at the bottom and the green is at the top. They mix a little bit together. But since the red is so jam-packed with sugar, it goes to the bottom. It's more dense. The green is less dense, so it stays more at the top. So more dense is at the bottom and the less dense is on top. More dense means that the objects are more tightly, or the atoms are more tightly packed together. Less dense means that the objects are less packed together. The less dense objects go to the top. Let's see if we can do this again. You can see here the green is going to the top. That is because the green is, that's right, less dense than the red. The green is less dense because all of those sugar molecules are a little more spread out. Whereas the red, the sugar molecules are more packed together because there's so much more. So if an object is more dense, it will go to the bottom. If another object is less dense than another object, it will go to the top. An object is dense if the molecules or the atoms are tightly packed together. An object that is less dense, the molecules or atoms are less packed together. So what we're going to do first is we're going to look at some objects and compare them to water. Are they more dense than water or less dense than water? Let's go ahead and see. Now that we have a better understanding of what density is, let's see if fruits are more dense than water or less dense. If an object, or in our case, a fruit, is more dense than water, it will sink. If it is less dense than water, it will float. The objects that we will be testing today are an apple, a strawberry, a grape, a tomato, a blueberry, a papaya, a lime, and a watermelon. Which objects do you think are going to sink and be more dense than water, and which objects are going to float and be less dense than water? First, we have a tomato. Will it sink and be more dense than water, or is it less dense than water and will float? What are your predictions? Ooh, let's find out. It sunk. That means it's more dense than water. Tomatoes are more dense than water. Let's see what would happen with a blueberry. What are your guesses? It sunk. So what does that mean? That's right. A blueberry is more dense than water. Great job. Now we have a lime. Is a lime more dense than water or less dense? Let me hear your guesses. Some of you think that it's big, so it's going to be more dense than water. Let's go ahead and drop it and see if you're right. Whoa, the lime floated. That means it's less dense than water. So it's looking like size doesn't matter. Let's take a look at our next object. Now we have a grape. Is a grape more dense than water or less dense than water? Let me hear your predictions. Ooh, I heard some people say less dense and some people say more. Let's find out. That went straight to the bottom. So the grape is more dense than water. Now we have a papaya. What do you think a papaya is? More dense or less dense? Well, it's similar size to the lime. What are your guesses? Is it more dense or less dense? Okay, let's go ahead and see if you're right. It sunk, so it is more dense than water. Was your prediction right? Awesome! If it wasn't, no big deal. Let's see if you can get the next one. Next, we have a strawberry. Will a strawberry be more dense than water or less dense? Okay, let's go ahead and find out. It is less dense than water because it floated. Scream out your predictions for an apple. Is it more dense than water or less dense? I don't know. That wasn't loud enough. Say it a little bit louder. Okay, I heard you. Let's test this one out. This apple is less dense than water. I wonder if you tried different apples, if all apples are less dense than water. Seems like an experiment you should try at home. Buy a couple different apples and see if some sink and some float. But this apple is definitely less dense than water. Is a clementine more dense than water or less dense? Oh, interesting. Somebody said that when it is peeled, it will be less dense, but with its outer shell on, it will be more dense. Ooh, let's try both of them. Great thinking. So with the clementine skin, it floats. It's less dense than water. Now if I peel this, what do you think? It's going to be more dense or less dense? It's still less dense than water. Now, let's just try one of the slices. What's your prediction? Whoa! One of the clementine slices is more dense than water. That is pretty neat. A watermelon. This is getting me excited for summer. Now, is a watermelon more dense than water or less dense? I heard a little bit of both. Let's go ahead and try out this delicious watermelon. The watermelon floats. That means it's less dense than water. That one surprised me. Now that we know a little bit about being more dense or less dense than water, let's try different liquids and maybe throw some solids in there to see if they're less dense or more dense than each other. Now if I have heavy cream, honey, and maple syrup, and I put them in the jar, which one do you think is going to go to the bottom? Which one do you think is going to go to the middle? And which one do you think is going to go to the top? Remember, the most dense will go to the bottom, and the least dense will go to the top. Let me hear your predictions. Those are some good predictions. Let's go ahead and find out which is the most dense and least dense. So the most dense was, which liquid is on the bottom? That's right, the most dense was the honey. You can see that it's lighter at the bottom. What liquid is in the middle? Good job. The maple syrup is in the middle. Now, which one is the least dense? Great job. The milk is the least dense, and that's why it's on the top. Now let's try it with some solids and liquids. So first we have some water. I'm going to add some food coloring to it to give it some color. Next, I'm going to stir it in. Now I'm going to add some maple syrup. Do you think the maple syrup is more dense than the water or less dense than the water? Ooh, I heard some of you say it's going to be more dense. So if it's more dense, will it go to the bottom or top? Let's go ahead and see if you're right. It's kind of hard to see here, but the maple syrup actually went to the bottom. We'll be able to see it after we add our next object. Next, we're going to add vegetable oil. Do you think vegetable oil is more dense or less dense than water? Do you think vegetable oil is more dense or less dense than maple syrup? With those guesses, will the vegetable oil go on top, in the middle, or on the bottom? Let's go ahead and find out. Now this one's easier to see. Is the vegetable oil more dense or less dense than water? Less dense, that's why it's on top of the water. Is it more dense or less dense than the maple syrup? Less dense, that's why it's on top. You can see with the flashlight on the bottom, you can kind of see the brown maple syrup, and in the middle you can kind of see the water, the green water. And on top, you can see the vegetable oil. Let's move it to a lighter place and see if you can see the different layers. That's so much better. Now you can easily see the maple syrup on the bottom, the water in the middle, and the vegetable oil on top. The maple syrup is on the bottom because it is more dense. The vegetable oil is on top because it is less dense. What we are going to do is we are going to now take some objects and find out if they're more dense or less dense than the liquids. Our first object is a blueberry. Do you think the blueberry is going to be more dense or less dense than the maple syrup? What about the water? And what about the vegetable oil? If it's more dense than something but less dense than something else, where do you think it might land? I'm going to go ahead and drop this and see if your predictions are right. So the blueberry landed above the water and above the maple syrup. So it is less dense than the water and the maple syrup. But it is more dense than the vegetable oil, and that's why it is below the vegetable oil. I wonder what other fruit we can see. Now we have a dime. Where is a dime going to go? What is it going to be more dense than? Is it going to be less dense than anything? What are your predictions? All right, let's see if you are correct. The dime goes all the way to the bottom. That means the dime is more dense than all the liquids. Now let's take a look at a grape. Where do you think a grape is going to go? What is it more dense than? What is it less dense than? Ooh, I heard someone say it's going to be more dense than the water, but less dense than the maple syrup. Let's find out. What is the grape more dense than? Great, it is more dense than the vegetable oil. What is it less dense than? Yes, it's less dense than the dime, the maple syrup, and the water. And it's about the same density as the blueberry. Nice job! Thanks so much for learning about density with me today. Maybe you can go around and find some objects or liquids around your house and see what's more dense or less dense. Or fill up a glass of water and try to see what's more dense or less dense. I had fun today. I'll see you next time.